Section 3.3.13-T. Male and female populations of giant clams under 80 years old are represented by age in the table over here to the right. We want to complete parts A through D. So the first thing we want to do is we want to approximate the population mean and standard deviation of age for males. So let's go ahead and do this on StatCrunch. We're going to open up this table in StatCrunch. So now we have our information. We have our age, we have the males, and then we have females. So if we want to find the population mean and the population standard deviation for the males, we're first going to then go to Stat, and then we're going to select Summary Stat, and then go to the Group Bin Data. And then the bins in is going to be the age, and the counts in is the males. And we want to find the consecutive lower limits. And we want to be able to find the population mean. Now this standard deviation is for the sample. What we want is the population mean, so we're looking for the unadjusted standard deviation. And then we're going to select Compute. Okay, so there is our information for the males. Okay, so we can say here that the population, we're going to call this the mean population for men, is going to equal 43.7, or we'll say 43.8 since we'll round that to one decimal place. Okay, let's rewrite that. So for the men here, we're going to say that this is equal to 43.8. Okay. And then for the population standard deviation for men, we can round that to one decimal place. That'll be 20.7. Okay. And so now what we're going to do is we are now going to, and again, we got the mean from here, and then we have the population standard deviation. Now let's go ahead and then figure this out for the women. So we're going to go ahead and then select Stat. We'll go to Summary Stat again, just to kind of go over this again, and then go to Group Bin Data. The bins in are the age, the counts in are for the females. We want the consecutive lower limits, we want the mean, and then we want the unadjusted for the population standard deviation, and then we're going to select Compute. So now we have the approximate summary statistics for the females. And so the population mean for the women, rounding this to one decimal place, is 44.5. And then the population standard deviation for women is 18.8. Okay, so now the question states, which gender has the higher mean? Well, if we look here, we know that the mean for the men is 43.8. The mean for the women is 45.5, which is females. So we're going to say the females have the higher mean age. So we can say that the females have the higher mean age. Now, which gender has the higher dispersion in age? Well, the standard deviation is the measure of dispersion. And you can see here that the males have the greater dispersion because they have a higher standard deviation. So therefore, it's the males that have the higher dispersion.